Good morning, my YouTube viewers. It's Crystal here, and what I wanted to do this morning is I wanted to go over the code review of a random forest code from scratch. And basically, I got the code from Python in Plain English and Random Forest from Scratch article, and this is the blog post right here if you want to look at it. So that's where I got the Random Forest from Scratch code. And so the first thing you have to do in order to get the Random Forest from Scratch code is you have to run up the decision tree code, and the reason why is because the random forest code is composed of several decision trees. So you go on to the decision tree, which is another article, but you can find the article in the Random Forest from Scratch article, and you call up the decision tree code. So you import NumPy as NP, and then from collections you import counter. You do the a function for entropy. You do your class node. So it looks to me like they're using object-oriented programming, and I haven't really used a lot of object-oriented programming. I know I'm going to have to learn it at some point in my data science career, but I haven't learned it yet. You do a function on your leaf node, and then you have your class decision tree. So you do your def init, your def fit, your def predict, your def grow tree, your def best criteria, your def information gain, your def split, your def traverse tree, your def most common label. And then what you're going to do is you're going to import the data sets, because we're spending a lot of time making the code for the algorithm. So we're just going to import a data set. We're going to import sklearn, train test split. You're going to create a function for accuracy. And what I will say is the accuracy function works better than sklearn's score function. I found that out when I was trying to do it. You're going to upload the breast cancer data set. You're going to define your X variable as data and your Y variable as target. You're going to do a train test split. And one thing that I will say is the person who did this code did not shuffle the data set, which she should have shuffled the data set. So I went ahead and added the code shuffle equals Y, so the data set would be shuffled. And so you define your model as CLF equals decision tree, max depth equals 10, and then you fit the training data into the model. And YPRED1 equals CLF dot predict X train. ACC1 equals accuracy Y train YPRED1. So you get your accuracy, your training accuracy is 1.0. So that's where you get your training accuracy. So I don't think that she has, she didn't predict on the test set, which I think really she should have done. But we're going to let that go for the time being. I think after I finish this video, I'll go through and do the test accuracy and see what it says. But we're just going to go ahead and go to the random forest. Now this is your code for your random forest. And what a random forest is composed of several decision trees. And that's why they call it random forest. So you're going to import NumPy as MP from collections import counter, and then you're going to define your bootstrap function, and you're going to define your most common label, and then we're going to define the class of random forest. So you're going to come in directly to your random forest. You're going to define your init, define your fit, define your prediction, and then from sklearn we're going to import data sets. From sklearn.model-selection import train test split. You're going to have your accuracy, which is good because the score function on sklearn didn't work, and because the score function didn't work, I had to use accuracy. But the accuracy is really good. Accuracy equals np.sum y true equals y pred over length of y true, and you return your accuracy. Excuse me, it's early in the morning. And data equals data sets dot load breast cancer. So we're going to do the breast cancer data set again. X equals the data, Y equals the target, and you're going to do train test split. And one thing that she didn't do was she didn't shuffle the data frame. So on the train test split, I went and shuffled the data frame, because you should shuffle the data frame to try to improve your score. CLF equals random forest, n trees equals 7, CLF dot fit x train y train, y pred equals CLF dot predict x train, ACC1 equals accuracy, y train, comma y pred, print accuracy, so you had accuracy of 100%, y pred equals CLF dot predict x test, ACC2 equals accuracy, y test, y pred, print ACC2, so you only had 97% accuracy, so we lost a little bit of information there. So now what we're going to do is we're going to compare this to the random forest classifier in sklearn. So from sklearn.ensemble import random forest classifier, model equals random forest classifier, random state equals 1, 2, 3. So I decided to make the random state the same as the random state that she had in her algorithm, and fit x train y train, and then y, so that means we trained and we fitted the data into the model. So y pred equals model.predict x test, so we're predicting on the x test. ACC3 equals accuracy, brackets y test, comma y pred, print training accuracy ACC3, so we had a training accuracy of 99%. So the training accuracy with sklearn's random forest classifier is higher than the training accuracy in this made from scratch classifier, but it's still very good random forest classifier. It's very good decision tree classifier. You know, I've been studying made from scratch algorithms, and it's, you know, one of the best I've seen. So that's it, really. Even though the made from scratch random forest classifier and decision tree classifier is very good, it still did not outperform sklearn's random forest classifier. So we're going to go ahead and conclude this video, and what I will do when I close the video, I'm going to try to go ahead and make predictions on the test set, which, because the lady who wrote this program, she didn't predict on the test set, so I'd like to go back and do that. So I hope you got some information out of this program. You definitely have the website that you can look on to get the code if you need it. And thank you so much for watching this video. If you like my video, please like, subscribe, and share. And I would like to thank my subscribers for supporting my channel. And I look forward to making more videos and blog posts for you in the future.